this video, we're going to be taking a look at Microsoft Access and how we can go from an ERD, that's an entity relationship diagram, into an actual database. But before you continue with this video, there are a few required readings and videos you should take a look at first to fill you in on some needed context. From your Experiencing MSI textbook, ensure you've read Chapter 5 and Knowledge Extensions 6 and 7. Also from past weeks, make sure you've watched the ERD tutorial videos and the database lecture video. There should be links to all of these on OWL, and having a foundation in these topics will be important to understand what we're going to be doing today. So let's get right into it and start talking about how we translate an ERD, or an ER model, into a real database. Recall that ERDs are the blueprints for our database that we use as a sort of instruction manual when we start building a real database. So these ERDs don't actually contain the data stored in the database, but rather a model that shows the structure of the database. So this provides a visualization that gives us an idea of what we could store in the database. So it contains metadata as opposed to the actual real data stored. So this visualization can be mapped to an actual relational database and provides us the documentation or a blueprint to follow when creating it. The idea is that we could take this ERD and hand it to another person, and it would have enough information for them to create our database, just based on that diagram alone, without any additional information. So here we have that university example from how to create an ERD tutorial slides from OWL. Today we'll be taking this ERD and turning it into a Microsoft Access database. As a quick review, this ERD showed a blueprint for our database that stores information about students, the courses they take, the professors who teach those courses, and the faculties and departments in the university. So in this model, students take courses and belong to a faculty, while professors create a course and teach courses, and they can also optionally be a department chair. So there are a few steps we should take when we're translating or transforming these entity relationship diagrams into a database. The first one's going to be transforming the entities from our ERD into tables in our database. So we should have one table for each entity in our ERD. Next, we're going to add the attributes from those entities as fields for the table and define the metadata. The metadata in this case would be things like field names, denoting primary keys, setting properties on the fields, and adding descriptions for each field. Lastly, we're going to add some rules or constraints to enforce the relationships between the tables. So all of these steps will start becoming more clear once we start getting into it. So let's start. Now we're going to switch to the desktop and take a look at Microsoft Access. So Access should be located on your desktop if you've installed it. There should be an icon that looks something like this. If that's not the case, click on your Start menu, type in Access. An icon should pop up as best match. Click on that and it will open Microsoft Access. So you get a screen that looks something like this. It should be very similar to what you'd get if you're opening up Excel. And it's a similar idea here. These are all different templates for making databases. However, for most of the stuff we'll be doing in this course, we're going to be using a blank database. So just click on Blank Database. This is going to ask where you want to save your database. So make sure you're saving it somewhere safe. If you're using MyVLab, make sure that you are saving it on your home computer and not the MyVLab computer, because you want those files on your own computer so you can submit them to OWL eventually if you're working on an assignment. If you want to change it from the default location, usually this is your Documents folder, click on the little folder icon. You can select somewhere else. I'm going to select the desktop in this case, and then you give the database some sort of name. Call it My Database. So it should end in .accdb, and that's the Modern Access extension. If it's saying something else like MCB or something like that, or MDB, that means it's one of the older formats. So you want to make sure that you're selecting the newer formats for Access 2007 to 2016. If that's not available, you're probably using an older version of Access, and you should update to the newest version. It is free at myoffice.uwo.ca for Western students, so you might as well update to the newest version. So after you have the file location set, just hit Create, and it will create your database. And when you first start up, Access is going to make a default table for you. Right now this is called Table 1, and it's going to just simply have a single field in it called ID. So for now, we're just going to take a look a little bit at the GUI before we start getting into doing anything in Access. So first of all, you should see this bar at the top here. And this should look a little bit familiar to you if you've used Word or Excel. And that's because it's using the same sort of ribbon format, where each one of these is tabs, and each tab changes the ribbon. So the Home tab is going to have some of the commonly used things. One of the big things we're going to be using is this button here that changes the view you're in. Right now we're in what's called Datasheet view. And this allows you to view the different records and fields in your database. So each one of these rows going down is a different record in the database, and each column is a different field in the database. Right now there's nothing in there because we haven't started editing it yet. So these formatting options over here allow you to change how the table appears. So if you said like size 22, it would change the fonts. It's important to note that these formatting options only apply to the whole table at once. So with Excel, we had cells that had both data and formats in them. In this case, the individual data entries in our database don't have any formatting associated with them. So this formatting changes everything for the whole table at once, not for individual cells or individual data. That's because the data entry isn't really saved with any formatting associated with it. So you don't have to worry too much about formatting, and it might just be helpful if the text is too small and you want to have a little bit bigger font so you can see it better. So the Create tab is going to have options for creating new things. We're going to have create new tables here. When we start getting into queries, forms, and reports, we can do that all here. There's the query wizard, there's the form and the form wizard, reports and the report wizard. So that's where we go to basically make new things in our database. The external data tab that has basically ways to either import data from other programs or other files or export our data. We'll be seeing later in the following weeks how we can import XML into Access, and we'll also look at how we can export some of this back into Excel. The database tools, the big thing here is going to be the relationships window, and we're going to be using that later on in this tutorial to enforce some of the relationships or the referential integrity in our database. Another big thing is the help tab. So this is a great spot to get help if you're stuck in your homework or doing your assignment. You can click on help and then click this help button. And it's going to bring up this little window here. It's just like the help in Excel. So we could type something in like create database. And it's going to have a bunch of tutorials and articles on how to do that. Sometimes there's even videos. So if we create, get this thing about all the steps how to create a new database or create a new table in Microsoft Access. So it's a great resource. I also have some resources included in the slides. So here you can see a list of different resources. So these are all optional resources. You're not required to read them, but they will be very helpful when you're working with Access. So the first one here called Access and Help and Learning, and it is a link if you're looking in the slides. These are also links that are under the supplementary resources on the OWL tab. And this first one's going to bring you to the Microsoft Access help site and the official version. And it'll allow you to type in search queries there. And these are also some tutorials from Office that will tell you how to do things like an introduction to Access, and they come with videos, like sort of give a video introduction to Access, how to create databases in Access, add tables, relations, forms, all kinds of things like that. So if you come to a point in Access where you're working on your assignment or some of those MyLab problems, and you don't know how to like create a new form, you can check out one of these, and I'll usually give you a video as well as a text-based tutorial on how to do that. There's also some third-party sites like Guru 99 tutorial. That'll be a good start for learning Access to have an additional resource outside of these tutorials and our e-textbook. So we're back to Access now, and I should mention that those slides that you can find on OWL, there's going to be the slide link right beside the name of this tutorial that you probably clicked on to get here. Also have a few appendices and also sort of a graphical tutorial in them. So if you want a little bit extra information, make sure to look at those slides because they have a little bit of extra content that's not included in the video part of this tutorial. We'll also see that we have two tabs that are only available based on what you currently have selected. So right now we have a table selected, so we have two table tabs. We have the Field tab, which allows us to add new fields and allows us to switch the views. And we have the Table tab, which has a few things for table properties and another way to get into that relationship menu. Right now we're in what's called datasheet view, and there's a few things that we have here. So along the top, we have all the field names, and each one of these is a column. So going down this way are going to be the rows, and each one of these rows represents a record in our database, or sort of an instance of the entity. So if this was a table that describes students, each record would be talking about an individual student. At the bottom here, we have the navigation controls, and I'll be talking about this a little bit more when we start entering data in our database, but it basically allows us to switch between records. It'll also be very helpful when we get into forms. On the side here, we have a list of basically everything that's in our database. So right now we just have table 1, but as we start adding tables to it, you'll see that I'll start adding those tables on the side. And this is a way that we can quickly switch between different tables. Also, when we start adding reports and forms and things like that, they'll also be listed over here. Along the top here, we're going to have tabs. Those will be all the open tables. And in the second tutorial, the extra example, I'll show you how you can switch to a different windowed mode. For this tutorial, we're going to be using the tabbed mode. So that's all for the basics. In the next part, we're going to actually get in to start making some of these tables and adding some fields. That brings us to part 2, adding your first table and fields. On the left here, I have Microsoft Access opened, and on the right, we have that entity relationship diagram from last week that describes Western as well as some students, courses, professors, faculties, and departments. So our first task is going to be taking these entities, like student here, and translating them into tables in our database. So we want student to become our first table. Right now we're in what's called datasheet view, and this shows us some records that are currently in our database, as well as all the fields. They become the columns, the records become the rows. Right now it's just the default table, and it comes with one default field called ID, so we don't really have anything in here yet. So we're going to have to add all the fields. So what we can start with is that ID field. You can see that in our entity, student, the primary key is called student number. So we're going to want our primary key in our table to also be called student number. So we can rename this field by double-clicking and just typing in the name. In this case, student number. You notice that I did not include a space in student number. Not having spaces in the field names makes it a little bit easier when we start getting into SQL and queries, but Access does support and allow you to put in spaces if you wanted. That's fine, but I do recommend not having spaces in your databases just because it'll get easier when we get into SQL. There'll be less work. You also note that the field names we use here don't have to be exactly the same as in our ERD. For example, I could say student num instead of student number. That's perfectly fine as long as it's clear what that field became. It doesn't have to be exactly one-to-one in terms of the names. We have student number in now, so we need to add all these other fields from student. So we have name, date of birth, faculty ID, registration date, and so on. So in datasheet view, we have an easy way to add a new field. And you can see it already here in yellow. It says click to add. And what this means is it's click to add a new field. So we can do that by just clicking to add, and you'll see a bunch of options pop up. And these are the data types. So this is a type of metadata that describes the data type for that field. So the first one we have here is a number, but the second one we're going to be adding name. So that's going to be short text. Short text means that it's going to be some plain text that's less than 255 characters. So we'll call this name. And I'm going to push enter. And you'll see that we get a little error pop up. And this error says the name you supplied is a reserved word. Reserved words have a specific meaning to Microsoft Access, or it's the Microsoft Access database engine. So what this is saying is that there's certain words in Access that have special meanings, especially when we start getting into SQL and queries. And the name that we typed in, which is just name, conflicts with something that's already built into Access. So in this case, we should probably name it something else. Instead of name, we'll go with student name. And like I said, it doesn't have to be one-to-one, as long as it's clear what it is from your entity relationship diagram. Another thing you might be seeing is the student name is slightly cut off. And that's because these columns, these fields, have widths just like they do in Excel. The only difference here is they don't really affect anything. It's just how we're viewing the data currently in the database. And you can change these widths the same way that you do in Excel. You hover over the line between the columns, and the cursor will change to this sort of arrow symbol, and then you can drag it to the left and right to change the widths. So these widths, again, don't affect the actual width of the field in terms of how many characters it can store. It's just a visual width for when you're looking at the data. We're going to go on and add another field. In this case, we have date of birth. So in this case, we do have a nice data type called date and time that we can use. So we should always try to use the data type that closely matches the data that's going to be stored. So this is going to be a date, so we want to use date and time. And instead of calling it date of birth, I'm just going to call it DOB. So the next one is going to be faculty ID. And if you recall from our ERD, the faculty ID is a bit of a special case. It's a foreign key to another table. So the faculty ID is always going to match up with the faculty ID from the faculty table, where it's the primary key. So it's important when designing your tables that when you have a foreign key like faculty ID, that it's going to be the same type as it is in your faculty table. So in this case, we're going to call it a number, but when we start making that faculty table, we're going to have to make sure that it's also a number in the faculty table. Call this faculty ID. You also notice when you hit enter, it'll automatically bring up the list to create another new field, just to make it a little bit easier for you. And down here, the next one is registration date. So that's going to be another date, so we can select date and time. We can call that reg date. So you might be wondering what all these different data types are. I described short number, and date's pretty self-explanatory in number, but I do, in the slides, have a nice chart for you that describes the most common data types you'll be using. So short text is just going to be plain text. That means it doesn't have any formatting, and it's up to 255 characters. And there's also long text, and that will store up much more longer lengths of plain text, up to 64,000 characters. We have number, and that's going to store numeric data, so that could be whole numbers or it could be decimal numbers. We have date and times for dates or times. We have currency for monetary values. We have AutoNumber, which is a bit of a special case we'll be getting to later. We have yes or no, that's sort of a Boolean value, that's either true or false. So if we have a value in our entity relationship diagram that's always going to be yes or no or true or false, we can use that. And we have the type hyperlink, and that's for storing links to internet sites or local files on your own computer or on the server if this was the database on the cloud. So one thing that's important to note, you'll see that we have things like short text and we have things like long text. So you should always be using the data type that requires the least amount to accomplish the goal, because each of these will have a different amount of size they take up in your database. So if you went along using long text for everything, it's going to be less efficient when we come to queries and storing the data than it would be short text. So if you don't need thousands of characters, you should be using short text. And those slides do have a bunch of appendices. So if you want to get to those on OWL, just click on the slides link that's beside the name of this tutorial. Now that we have the fields in, we're going to have to start setting some metadata on them. And we can't really do that well in the datasheet view, so we're going to have to change our view to what's called the design view. And you can do that by clicking up here where it says view. And you can either click down here and click on design view, or whatever view you're in, if you're in datasheet view or if you're in design view, clicking the view button up here will always switch you to the opposite one. So we're in datasheet view right now. So if we click up here, we'll be switched to design view. So what it came up right now is it says save as. Because this is the default table and we haven't saved it yet, it's asking for a name for this table. So we're going to call this table student. Notice that I typed it in all capitals because we want to keep that all capitalization name scheme going for our tables, just like we did with our entities. And we'll use the lowercase for the relationship entities rather than the object entities. The reason we do this is we'll make it really easy when we're looking on the side here to quickly pick out what's an object entity and pick out what is a relationship entity. So I named it student and I hit OK, and that saves the table. So if we go back for a sec, if you wanted to save at any time the changes you've made to the table structure, you just right click on student and you click save, or it will be whatever name your table is. So when you first get in there and you see it says table 1 and you want to change that to the name like student or courses or whatever your case may be, you right click and hit save, and it will come up with a little thing asking you what name you want to save it as. So now that it's all saved, we'll go into the design view. So we click here. So now we are in design view. And design view shows us the fields in our table, as well as the metadata associated with those fields. So in this first column here, we have all of the field names that occur in our table. In the second column, we have their corresponding data types. So in this case, it says student name is short text, date of birth is a date time, faculty ID is a number, and so on. Now, this third column over here is the description column. And this allows us sort of to document our table. So right now I have DOB for date of birth. If I come back to this years later, I might not be very clear what DOB stands for. So the description field allows us to add comments and sort of notes. So I might say, this is the student's date of birth. So these little descriptions don't have any effect on our database. They're just notes for when we come back to it later to document the database. So the next big thing in this view is this big thing going on down here, the field properties. And this is the metadata about each field. So there is more metadata than just data type and description. There's quite a lot of different types of things we can set for each field. And I'll go through some of the most important. So we'll start with student name. That's a short text. So based on the data type, we'll have slightly different field properties we can set, but there'll be some that are always the same. And one of those is required. So right now it says required no. So this is like saying that it is nullifiable in our entity relationship diagram. So by saying required no, it says this field does not have to be filled in each record. So since we can look in our ERD over here, we can see that name is listed as a required attribute of student. So we want it to be required in our database too. So we set this to yes. And that means that when someone's entering data into the database, they have to put in a name for a student name, or that record won't work. We also have something similar called allowed zeroed length. So this refers to strings or short text, and this is saying that the length of that text has to be greater than 0 or not. So if we say yes, that means we're allowing it to be 0, so we could just have like empty text. If we're saying no, then it has to be greater than 0, so there actually has to be data in that text. So since this is required, we also want that to have actual text in it, so we want to say no here. We don't want to allow 0 length. The next property down here is indexed. So this is a special property that tells the database whether this has to be unique or not. This is sort of like the unique setting in our ERD when we're using the DIA editor. So there's a few options here. So there's no, so that means that it doesn't have to be unique. We could have 2 students with the same name. There's yes, duplicate's okay. So this is a sort of in-between setting, and this says that the database is going to keep track of this field just in case we need to search by it, but it is going to allow duplicates, so we can have multiple students with the same name. And then there's yes, no duplicates. So we said yes, no duplicates. This would be like setting it to unique in the ERD. This would be saying that every record in this table cannot have the same name. So we don't want to set that for our student name, because it is possible that we could have 2 students with the exact same name in our university. So we're going to set no. The other settings down here aren't quite as important. One of the important ones is up here. This one's called field size, and this usually shows up for text fields. And this says how many characters can be stored in this field. So right now I have it set to 60, but if we wanted students to have up to, let's say, 120 characters, we could do that. So this is the maximum number of characters they can have in this field. By default, it's usually 255 for short text, but usually that's a little too much for a name. The next one we're going to take a look at is date of birth. So date of birth is required on our ERD, so we're going to set that to yes. It's not unique, so we keep this as no. Go to the next one, faculty ID. So that is going to be required according to our ERD. So it's going to be indexed because it's a foreign key by default, but it says duplicates okay. So we can leave it as yes, duplicates okay, that's fine, as long as we don't have yes, no duplicates. If we had yes, no duplicates, that would mean that we could only have one faculty ID for each student in terms of it being unique or not. So if we had 2 students with the same faculty ID, that wouldn't be allowed. But in real life, we have many students from the same faculty, so we want to allow duplicates okay. Another thing, since this is a number, we get another different option for field size. So instead of a number, we have a few different settings down here. We have byte, integer, long integer, single, double, and decimal, and a few others. So I do have a slide that shows what these mean. And you'll notice here that there are a few different slides in this slide deck. And basically what these are both appendices that list things like these data types, as well as sort of like a visual tutorial. So if you didn't want to watch the video to look over some of this, these slides will give you sort of like image-based tutorial as well. And again, you can find these by clicking on the slides link beside the tutorial name. And anyway, one of these slides contains this table called number field sizes. And this is specifically for number fields, the different settings we can have for field size. And this affects how big of a number we can store. So for example, if we set it to byte, we can only store numbers 0 to 255. If we set it to integer, we could store numbers from negative 32,000 something to positive 322,000 something. So one important thing to note is these ones, byte, integer, long integer, only store whole numbers. So if we're using an integer, a long integer, or a byte, that means the number we're storing has to be a whole number. If we want to store a decimal number, or a number with decimal points, we have to use decimal, single, or double. So in this case, the faculty IDs are going to be full numbers, and we probably want to let our database go up to quite a large number of faculties. So we could either do integer or long integer. The important part, since this is a foreign key, is that it has to be the same setting as it is in the faculty table. So for now, we'll just leave it as long integer. I guess our university could get quite massive, theoretically. So we'll leave it as long integer, but we have to remember that it also has to be long integer when we make that faculty table. We have decimal places. This doesn't really apply to long integers, but if this was a decimal number, then we could set how many decimal places that number would have. For integers, it's always going to be a whole number, so the setting doesn't really apply. So registration date, we can see that for registration date in our ER diagram, it is listed as not required. You can see it has the little, it's hard to see here, but if we zoomed in a bit, we could see that it has the little symbol for not required. Back out. So that means we can leave it as no for not required, and it's also not unique, so we can leave that as no. So all the default settings are fine here. So if we wanted to, we could go in and add a few more descriptions. So this is the faculty ID from the faculty table. So a big one to document is always your foreign keys, because you want to know how they're linking to other tables. It might not always be completely clear. Because remember, we don't have to use the same name for the foreign key as we do as the primary key in the other table. They are allowed to have different names. So say we wanted to modify our table eventually and change what the primary key is. So maybe we don't want a student number, maybe we want some other special student ID. The way we could go about changing that is we'd go to student number and we can click this primary key button up here, or we could right click and select primary key, and that takes away the primary key property from student number. And then we could add in, insert a new row. We could call this student ID. Set this maybe to a number. And then we could make this a primary key instead by clicking the primary key button. Or you could right click and click primary key. So now student ID here is a primary key rather than student number. That's not what we want in our case, so I'm going to undo that by deleting this row. In this case, a row is a field. So we click delete row. We hit yes. It's just giving us a warning about deleting the field with the primary key. And we hit primary key again just to set this back to primary key for student number. One thing we'll see is that student number's data type right now is AutoNumber, and that was that sort of special type that I mentioned before, and we'll take a look at what that does. So we're going to go back into datasheet view. And it says first you have to hit save, so we can just hit save. And you can see that we have all the fields up here, and now we might want to actually start entering data. So when we're in datasheet row, or mode, all of these rows now represent records, sort of like instances of students in our table. So to start entering them, we can start here. And one thing you'll notice, because this is a special type called AutoNumber, we don't actually have to put a value in for a student number. We can just start by student name. Let's say Daniel, put a date of birth in, and you'll notice because it's a date of birth type, it knows to pop up a calendar. So we could just select some date of birth, a faculty ID number. So for now, we don't have a faculty table, but once we actually get faculty IDs in there, we're going to want to make sure these match up correctly with faculty IDs that actually exist. For now, I'll just set it to 1, registration date, click on that. So right now I'm just navigating through this using the mouse. And then you'll notice that there's a little writing icon, sort of like a pencil icon here. It might be a little bit hard to see, but if you look closely, it's a pencil right now. So that means we're currently editing this record, this row, and it hasn't been saved yet. So as soon as you click away, that record's saved and the little pen goes away, and this record has been entered in the database. And one thing that's interesting, you can see now that it automatically entered a student number with the value 1. That's because that's an AutoNumber, and AutoNumber is going to automatically fill in numbers for us that are unique. So we can add another student. So if we try not entering a date of birth, because we marked that as required, you can see that it gave us an error saying that date of birth is required. So if we try to click away, it's going to keep giving us the error saying you must enter a value for student date of birth. So no matter what I try to do, it's not going to allow us to get out of this record without entering a date of birth. So if you're stuck and you want to get out, you can hit escape and it'll delete that record, because we're not allowed to enter a record unless it has all the required fields. So we can try that again and give it the required field. And you'll notice that the auto increment number has now gone up to 3. So it tries to get a unique number, but they always go in order. So if an update failed, or if you've entered a record and then deleted it, it's always going to start with the next number, even if that number doesn't exist in the database. So we can take a closer look. I'll enter this in. We don't have to put a registration date in because that's not required. So we can click away. So we'll put in another record. And one other way we can go through these different records rather than clicking on each one is using the tab key. So when I hit tab, it'll go over to the next field. I can enter a date and hit tab again. And I hit tab again. I can put in a registration date. When I get to the end and hit tab, it's automatically going to enter it, save it, and go down to the next row. So it makes it a lot more efficient using the tab key than clicking each time. To give a demonstration of the AutoNumber again, if I delete this record, and to delete a record, you can highlight it and right-click and hit delete record. And make sure you're sure, and click yes. Delete again. Yep, into yes, and that's just a warning saying you can't undo this. So you have to be careful when you're deleting things because you're not going to be able to easily undo them. But when we start adding another one, say Bob, you'll notice that the AutoNumber is now 5. So the AutoNumber keeps increasing and just guaranteed to be unique, but we don't know what the number necessarily will be. It's just going to be the next one. So it's not smart enough to like sort of go back and put in a 3 because we don't have a 3. One thing you'll notice is that faculty ID here is always a 0, and there's a reason for that. If we go back to our design view, we click on faculty ID, you can see that it has a default value down here. Right now that default value is 0. So one of the properties for these fields is going to be default values, and this will be the value that it's going to put in by default if you don't provide one. So in this case, it is required. So we could remove the default value. That's fine, even when it's required. It just means that the user inputting the data is going to have to provide it now. It's not going to default to a value. So if we save that, and I'll go back to datasheet view. Now when we start typing it in, you can see faculty isn't automatically filled in. And if we were to try to get away without putting in a faculty ID, we're going to get an error saying that the faculty has to be entered because it is required. So the main idea behind the default values is just what it's going to be put in there by default if we don't give it something. So it can be helpful for the user if there's a field that's often always has the same value. But usually you don't want to put in a default value if putting that default value in would be incorrect. So in this case, I've removed the default value from faculty ID because there isn't really a default faculty in the university. If there was a default faculty that maybe students were automatically enrolled into when they first start university, then it might be more appropriate to put in a default faculty ID. And the default value applies to other types of field, not just numbers. So if we look at student name, there's also a default value. So we could say the default value is Bob. And when we go to the datasheet view, after we save, you can see that new record automatically has Bob in. But that's not really what we want, so I'm going to go and remove that. So the next thing we're going to look at is more advanced metadata and fields. So in part 3 of this tutorial, we're going to take a closer look at metadata, particularly formats and input masks. And these are a little bit more advanced features that will be quite useful for you. So we're going back to Access, and you can see that I've entered a few more records into our table. One thing I should point out is down here we have the navigation bar. What this does is it allows us to sort of navigate through these records a little bit more easier. So when we click the Next button, it jumps down a record. We hit the Back button, it jumps up a record, and we can hit the All the Way Back and All the Way Down buttons. And these aren't too useful when you only have a handful of entries, but when you have a massive database, they can be quite useful for quickly moving through the data, especially when there's multiple pages. This is Next record, this is Last record, this is New blank record, so this will automatically skip you down to where you're going to enter a new one. And we have Previous record, and we have First record. And then the thing in the center tells you which record number it is. And that is based on the actual number in the table rather than the primary key. So you can see in this case, this is the 6th record, but it has a primary key of 9. That's because, like we talked about before, the auto numbers don't necessarily go in the order in the table. They go by just the next available number. They just ensure that it's a unique number, not necessarily that it's the number in order. So what we're going to do is go ahead and switch over to Design View. And in this case, let's say that we want to add a phone number. So notice that I'm just typing in a phone number in the Design View, so we can add fields that way too. That's completely fine if you want to add a new field. And we're going to save the phone number as short text rather than a number, because phone numbers can have like dashes and stuff in it. And we might switch this to 10. Say that it's not required, won't have a default value, it's not going to be unique, 2 students could have the same phone number. When we go back to our datasheet view, we'll hit yes. One problem we might run into is that when we're entering a new student number or entering in phone numbers, make a little bit wider, we could enter in just basically complete gibberish. It doesn't have to be a valid phone number. So we might want to enforce little stricter rules in our database to make sure that these numbers are actual phone numbers and that they appear as phone numbers. So one way we can do that, when we go into Design View, is with something called an input mask. And this is a pattern that is going to have to apply, or any data that's entered into this field has to pass or match to be allowed to be entered. So the input masks have their own syntax, and I have a slide for you that describes that. And it's shown right here. So basically, an input mask works is each character in the input masks represents some sort of digit or letter that could be input. So for example, 0 represents a digit, 0 to 9, that they could input. Capital L and represents a letter that must be input. And we have a few special symbols like greater than and less than. That means that all the characters that follow have to be uppercase, or all the characters that follow have to be lowercase. This might sound a little complex at first, but actually this is quite straightforward. So for example, if we wanted to say that we could only enter in 3 digits, we could say 0, 0, 0, and it says that we would have to enter 3 numbers, 0, 0, 0. 0, 0, 0 would be those special patterns, so that represents not just zeros, but any digit. So if we look at this again, you can see that 0 represents they must enter a digit 0 to 9. So this now our input mask says that you have to enter 3 numbers. It could be any number, but they have to enter them. So when we go back to Design View, when we try to enter just gibberish now, we're going to get an error saying the value you entered is inappropriate for the input mask 0, 0, 0. So it's not allowing people to input any data that doesn't match our input mask. So for example, we could say 1, 2, 3. That'd be fine because it matches the input mask. But we couldn't say 1, 2 because that doesn't match the input mask. In this case, the input mask 0, 0, 0, so you have to input 3 numbers. So similarly, if we put in extra numbers, like 4 numbers, that also wouldn't pass the mask. It has to be exactly 3 numbers. And it could be like 0, 0, 1. That'd be fine. But it has to be 3 numbers. Take a look at that again. So if we want to expand this a bit, we know that phone numbers have the area code, that's 3 numbers. Then they have the next part, like that. So in this case, it has spaces, and it's going to automatically put slashes in when we click away. So what this slash means is it means a literal character. So slash space means a literal space. Here, slash space means a literal space character. So what this input mask is saying now is that it has to be 3 numbers, a space, a literal space key on the keyboard, another 3 numbers, a literal space key, and then 4 numbers. I go back to this table. So now you can see that it has sort of like these lines where we have to actually input data. So if we wanted to input a valid number, it would have to be 1, 2, 3, 4, 5, 6, 7, 8, 9, 0. And you notice that it knew that the spaces were there, so it actually put the spaces in for us and moved the cursor right to the next number to make it a little bit easier for entering the phone number. This still isn't a perfect mask because usually we want to have like dashes in the phone number and brackets to make it look a little bit nicer. So one way we could do that is we could update our input mask, and we could use backslash again because that's saying it's escaping that character, so it says it has to be a literal bracket character. Here we could change that to a dash. So now we're saying a literal bracket, 3 numbers. They could be any number, but they have to be 3 numbers. A literal bracket, a literal space, 3 numbers, and then we're saying a dash, the literal dash character, and 4 numbers. So we go back to data view. We can see that for some of them that already match, it's added in those characters for us. But now when we type, you can see that it already has the brackets, the literal characters, and just is requiring us to enter in the numbers. So I can just type in 1, 2, 3, 5, 6, 7, 8, 9, 0. So it both formats it, and it makes sure that we are only putting in valid stuff into the database. Notice that it doesn't affect fields that have already been entered. So for these, we'd have to go back and edit them. But when we try to click away, it is going to allow them to be in like that. So it's only going to affect new ones. So if we try to put a new one in that didn't match, we get the error. But if it's already in there after the input mask, it's not going to go retroactively affect it. And that's why it's a good idea to have all your metadata set up before you start entering stuff into your database. Otherwise, you could start getting inconsistencies like that. So again, you can hit escape if you just want to exit out of inputting some new data. So Access also does have some of these built in, so you don't have to know all the input masks. Sometimes they have the common ones built in for you. So if you click on this sort of ... character here, it'll bring up a little wizard, and it has a few built-in input masks for you. So there's postal code, there's social insurance number, there's password, and a few different ones. So we could have just selected phone number, and it even lets you try it out here. So you can test out what the input mask would be like, then hit next. And mask here. Notice their input mask is a little bit different. It includes 9s. So the 9 character, if you remember from that chart, means that it's an optional number. So in this case, the area code is optional. It also lets you select a placeholder character. So this is that character that we saw when we hadn't input a number yet. When it says input a number here. So with the dash, it means it's going to show us a dash when it wants us to input a number. We could change that, for example, to a pound sign. It would show pound signs. So we can give that a try. And it's asking us how we want to actually store the data in our database. So we can say without the symbols like this. So this would be how the raw data actually looks in our database. Is it going to have those symbols, or is that just basically an appearance thing? Finish. You can see that their input mask is a little bit more complicated. But when we go in here, so now because we selected those pound signs, it's showing a pound sign wherever it wants us to input something. So we could do it again. Let's do it the other way. And remember that it had 9s instead of 0s for the first bit. So that means we could leave those out because they're optional to allow us to omit the first bit. If we wanted to change that and require the area code, go back to the input mask and change these 9s to 0s. That's now saying that we have to have numbers there. So if we were to try to do that again, let's clear this out. New one. If we were to try to omit the area code now, we get an error because we changed them to 0s that say we need that area code there. Another thing is right now we have student number set to AutoNumber. So if we go back to here, we can see that we have number 1, 5, 9. It just keeps on increasing the number whenever we add a new record. So if we added a new one like this, you can see that we get the number 10. Maybe in our system we don't want to format student numbers like this. Maybe we have a special code for student numbers. For example, maybe we had SN and then maybe 4 digits, and that would be the student number. So the way we could do that is we go into the format for the AutoNumber for the student number field. And the format codes work very similar to the input masks. So in this case, we could say we have SN, so a literal S, a literal N, and then we want to say we have 3 numbers, 0, 0, 0. So this would be saying the literal S character, the literal N character, and 3 zeros. Since this is a format property and not a input mask property, what it's doing is it's just changing how the data appears. It's not changing how it's entered, or it's not a restriction on how it's entered or stringed. The other thing to note, you can see how I did /s/n. It converted it to SN in quotes. So that's another way of saying literal characters. If you put anything in quotes, it means that that's the literal character. So the literal S, the literal N, and then followed by 3 digits. That could be any digit. So when we look at the table, you can see all the student numbers have now been reformatted to say SN for student number, and then 001. So when we put in the new one, you could say Kate. And you can see that it auto-incremented the number up here. So it's important to note this isn't changing how these numbers are stored in the database. It's just changing how we're viewing the numbers. So this is still a 1, this is still a 5. It's just changing how we see them visually. So we put 3 zeros, 0, 0, 0. So that means that there always has to be 3 places. There's always got to be 2 zeros and then a number. If we kept on entering them all the way up to 100, it would still fill in, but it means that for the numbers lower than it, it always has to be 3 digits in width. We went here and then removed the leading 2 zeros and just put 0. Then it says it has to, at a minimum, take up 1 place. So it still works fine when we get to higher numbers, but it just means that it's not going to add those leading zeros. So we can also apply formats to text fields. So we saw how we applied an input mask to phone number. We'll see how we can apply a format to student name. So if we take a look at our chart again, so let's say we wanted student names to always show up in capital letters. So we see that there's greater than sign, convert all characters that follow to uppercase. So we simply put in a format of greater than. When we go back to our table, we can see that now all the student names are in uppercase. But it's important to note that this isn't an input mask, this is just a format, so it's just changing how we view it. So we could still type in new names that are in lowercase, and it won't have a problem with that. It's just going to change how they're viewed. So input masks restrict how we can put data in, and they change the format. Well, formats only change the format, only how we're viewing the data. So formats only change how we're viewing it, while input masks actually restrict somewhat what we can actually input into our database. So another appendix I have in the slides is this list of example input masks, and they include things like phone numbers, ISBN numbers, things for names. You'll notice that another one that they point out are these question marks that allow for optional letters to be put in. So you should take a look at these, and they'll give you a good idea of what's possible with these input masks. Once again, these are included in the slides on OWL. Now we're going to go back to Access, and we're going to start filling in some of these tables that we haven't got to yet. So the first one's going to be faculty. So to create a new table, remember this one was created for us by default when we started up Access. We go to Create, then we can click on Table. So there's two different options here. There's either Table or a Table Design. So we click on Table. That's going to create a table. It's not going to have a name yet, but it's going to open it up in Datasheet view. Not save that. If we hit Create and we click on Table Design, it's going to create a new table. It's also going to be called Table 1 to start with, but it's going to open it up in Design view. So the buttons don't have that big of a difference. It's just what view you're going to go into right away. Personally, I like going into Design view to make the fields first, but whatever you find easiest. We're going to start by entering the primary key. If we look at our diagram, we can see that it's faculty ID. And remember, this is a foreign key in student as well. So we have to make sure it's the same type. So in student, it was a number. So we're going to have to make sure it's also a number here. Now it's important to note that the names don't have to be the same. This doesn't have to be called faculty ID. It could be called like fact ID or something like that. So it doesn't have to match the same field name as in student. It just has to be the same type. So in student, it's a number. And it is required in student, and it was a long integer in student, so that's okay by default. And to tell Access this is the primary key, we click on the primary key button, and I'll put a little key icon beside it. So the only other field in faculty is name, but remember name is a reserved word. So instead of name, we'll call it fact name. Again, the names don't have to be one-to-one from your diagram. Since it's a name, we'll go with short text. And we don't think we're going to have too long faculty names, so we'll just go with 60 characters. In our diagram, it is required. So yes, we don't want it to have a 0 length, so we'll say no. And it doesn't have to be unique. All that's fine. And we can now name the table. So to name the table, we just have to save it. Right-click, save, and then we can name it. So in this case, we're going to use all capitals because it is an object entity. And we type in faculty. And we can see that it appeared on the side over here. So we can switch between tables now by clicking on the tabs up here or by clicking on the tabs over here. Either one will switch us between our tables. Right now we have nothing in our faculty table, but in our student table we are referencing a few different faculties, 1, 2, and 3. So that means we should have corresponding keys in the faculty table. We have keys 1, 2, and 3. So in the faculty table, we should make sure that we have those keys as well. Now, since I made faculty ID as a number and not an auto number, it's not going to automatically increment. So we'd have to manually type them in. Comp sci. So it didn't auto increment this time. But if we were trying to do 1 again and typed in, let's say, math, we're going to get an error, and that's because primary keys have to be unique. So even if it's not an auto number, it's just a regular number, or you could use a string for a primary key. Really, you can use any data type for a primary key you want, but the requirement is they do have to be unique. So if we're not using an auto number, we have to ensure that uniqueness ourselves, or it won't allow the entry. And 3. We'll call this purchase. So one important thing to note when you're not using an auto number as a primary key and you're using number, for example, in this table, if we were to go back into the design view and then we say later, oh, maybe we want this to be auto number, we're going to get an error. And that's because there's already data in the table that's not using auto number. So after we start inputting that data, we can't then change it back to auto number later. To do that, we'd have to go back to the table. We have to delete what we have in there. And we go back to design view and now allow us to change it to an auto number when there's no data in it. So this is again why you should only be entering data after your tables are fully designed. We can input the data again. In this case, we don't have to enter the faculty ID because the auto number is going to fill it in for us. and that's fine. So another thing to note about AutoNumber is once we're using AutoNumber, if we want to go and let's say change this to a different number, it's not going to let us do that. So when it's AutoNumber, it's completely up to Access to name these primary key IDs. So AutoNumber is useful because it's going to handle it for us, but it also is less flexible because it's going to be up to Access what the number is going to be. So now the next table we want to start inputting in is going to be the courses table down here. So again, to do that, we can go Create. We're going to click Table Design. Start inputting it. So it's going to take a course ID. Data type will be AutoNumber because that's going to be our primary key. We click Primary Key. Next, we're going to do Course Department. So we could just call it Department maybe. And that as text. Number, let's say. And section. It's usually a number as well. If it was text, we'd want to use the text. And now we're going to have prof ID, which is going to be the foreign key for the professor's table. We're going to assume that's going to be a number as well. So now we want to set some of the metadata. Required, because it's required in our ERD diagram. We want to make sure that it has text in there. Required as well. Required. And that's also required. One thing we might want to do is for the numbers, not give them default values, because a course number of 0 doesn't really make too much sense. So remove those default values. We could leave these as long integers, but since we probably aren't going to have courses in that high number, we could set them to integer. Space. We'll leave this as long integer, and we'll have to remember to make sure that a professor ID and a professor table is also a long integer. And then we click Save. We'll call this course. And now we have a courses table. Like in the datasheet view, it's pretty straightforward. I'm going to go through and create each one of these tables. I'm going to fast forward it a little bit just because it's going to be pretty much the same thing you've already seen. So now that we have all the object entities in, we're going to have to start making these relationship entities like takes and teaches. Start with takes, and just like with other tables, we're going to go create. I'm using the table design mode. You could do it in the datasheet mode too. That's fine. We can call these whatever we want. They don't have to be the exact same name as, for example, in the student field. So we could call it studnum. And we call the other one course ID. And instead of auto numbers, because we don't want these to auto increment in this case, we're just going to set them to numbers. But they do have to be the same field size. And they also have to be required, because we can't really have one without the other. Represents the relationship between a student taking a course. And there's also some relationship attributes, the enrollment date. Call that a date. Required, let's take a look. Looks like enrollment date is required, but final grade is not. Out. Call this grade. It's going to be a number. So to note for grade, maybe we want a grade that can have decimal point precision. So instead of a long integer, we want something that can actually support decimals, like a double. A double is a type that has decimal numbers. We could also use a single or a decimal value. In this case, we'll just go with single. And let's say we wanted to have 2 decimal places. So we go to decimal places and we select 2. So it's going to be a grade that has 2 decimal places. So it's important to note that if we want things to have decimal places, they have to be a single, a double, or a decimal. They can't be a type of integer or a byte. So it's important to change that field size type when we want something like a grade. Enrollment date, we want that to be required. That, and this time we're going to use lowercase, because that's the standard we're using, the naming convention, for relationship entities. We'll take a look at that. So like I was saying, we could have, let's say, student 1, course 2, enrollment date, and we can actually put in a grade that has decimal places now. We could have another student, same student, student 1, taking a different course, and that's fine. Grade 90. Okay, let's add one more record to this takes table. So we're going to add one for a new student, student with an ID of 2, and we're going to say student with an ID of 2 takes course 2, just like the first student. And we're going to give them an enrollment date. We're going to say it's the same as the first student. One thing you'll notice is that we're getting those zeros again when we're not entering anything. That might not be what we want. We might want to just leave it empty when it's not filled in. To do that, we just want to make sure that we have the default value removed like that, since this isn't a required field. Save, and now when we remove that, it will allow us to enter it empty. So it's important when it's not required, you should consider whether a default value makes sense for that field. So in this case it didn't, because if you don't have a grade yet, it shouldn't be 0, it should just be not entered. So this represents a relationship between the student entity and the course entity. So this first record here, we're saying student number 1 is taking course 1. So that means the student 1 is taking course 1. This record would be saying student 1 is taking course 2. This record would be saying student number 2 is taking course number 2. So this is how we represent that many-to-many relationship in a database. So we have another one over here called teaches. So we're going to enter that one now. So we could do the same thing, create, in design view. It's going to have a prof ID. Number, because it was a number in the professor table. And we're going to have a course ID. And that's going to be a number because that was also a number in the course table. And we have to keep these as long integers because they were long integers in the courses table and the professor table. So it's important that the field size remains the same. And these are both required. Since there's no relationship attributes, that's all there is going to be in this table. It's just sort of relating professor ID with a course ID. And we'll save that, and we call it teaches. And that would work just the same, where it's going to have a professor ID and a course ID, and that means that that professor teaches that course. And once again, you could have multiple professors with the same ID, you could have multiple courses with the same ID, you just can't have them together with the same professor ID and the same course ID. So that wraps up how we're going to enter our tables, and now we're going to move on to relationships and how we can actually enforce those relationships. So in part 4 of this tutorial, we're going to talk about relationships in Microsoft Access and how we can enforce what we call referential integrity. So going back to our database, One thing you'll notice is that it allows us to enter student numbers and course IDs when they don't actually exist. So in this takes table that we made, we have a student number 2, and we look in the students table, there actually is no student with the number 2. Also, we look in the course table, there's no courses at all. So that's a problem, because basically it's up to the person entering the data to make sure that those relationships actually make sense, that those foreign keys are actually matching up with real primary keys. So Access does provide us a way to actually enforce what we call referential integrity, which is enforcing those relationships to make sure you're actually entering valid foreign keys, entering valid primary keys, and making sure all the relationships make sense. The way we do that is with the Database Tools tab, and we click on the Relationships button. Okay, here we have the Relationship Design tool. What this does is it lets us define the relationships in our database. So the first time you access this tool, sometimes you'll see a little pop-up that says, show which tables. If that doesn't pop up like I have right here, just click this Add Tables button. And I'll have a list of the tables in your database that you can add into the Relationship Design tool. So you could add one at a time by clicking them and hit Add Selected Table, or you could select multiple at once, like this, and hit Add Selected Tables, or you could simply just double-click. All of those work. And what this is it's sort of a visual representation of the relationships in your database, very much like an ERD, but it's a little bit different, and it actually affects our database, in that it defines the relationships. So first of all, I have the ERD up here, so I'm just going to move them a little bit to sort of be in the same positions. Makes it a bit easier to work with. Put takes down here, courses over here, here, teaches here. So the actual location of these doesn't matter at all, but it does help to just lay things out nicely to get a better view of everything and make things easier to work with. Okay, so now that we have everything out, or laid out, we can start actually defining these relationships. So we can start here with the relationship between student and faculty, which is a many-to-one relationship called registered. So to define a relationship, you have to drag the primary key to the foreign key. So in this case, faculty has a primary key of faculty ID, and student has a foreign key called faculty ID. So we drag the primary key here, click on it, and drag over to faculty ID in student, the foreign key. So if this worked correctly, you should see faculty ID for the faculty table on the left, and faculty ID for student on the right here. Now, one of the things to check when you're setting this up is that the relationship type is correct. So it says one-to-many. That's good because this is a one-to-many relationship that we're defining. Now, one of the things we want to do when we set up relationships is enforce referential integrity. Referential integrity basically tells the database that we want to make sure that when we're adding, for example, a student number to like the takes table or a professor ID to the teaches table, that's an actual real student ID, or that's an actual real professor ID that's already in our database. We could have some pretty big problems if we could just put in any number in there, and it doesn't actually correspond to a real student. So by enforcing referential integrity, we make sure that everything has to match up correctly, and if it doesn't, Access won't let us input that, and it'll show a little error. So we'd select Enforce Referential Integrity, and then we'd hit Create. Now in this case, there's going to be a small error because there's something we overlooked. So we're getting an error that says the database engine could not lock table student because it's already in use by another person or process. So if you get this error while working on your assignment or doing some of the homework, don't panic. All this means is that we already have all these tables open, and all tables have to be closed while we're using the Relationship Design tool. So this is easy enough to fix. We just close the tables. If any of these are unsaved, it'll pop up just like that and ask us if we want to save them, and we could just say yes, and we just keep closing them until everything's closed. Now we repeat the same step, dragging faculty ID to faculty ID, and we should now be able to create the relationship. And you'll see it uses a little bit different notation than we use in this course. So in here we have an infinity symbol for many, and we have all the number 1 for 1. So this is still a many-to-one relationship. It's just shown a little bit differently. This also only shows the cardinality. It doesn't show the participation. So let's keep defining a few more. So between student and takes, we have student number here, and that's the primary key of student. And we have stud number down here in takes. Remember, I named this one a bit differently. It doesn't matter if the names are different. They don't have to be identical, as long as we know this is the foreign key. So in this case, we drag student num to stud num, and we enforce referential integrity. It says many to one, which is good. But we are getting a little bit of an error here. So this time we're getting a different error. It says Microsoft Access can't create the relationship and enforce referential integrity. Data in the table takes violates referential integrity rules. So what this is saying is we're trying to set up referential integrity, like I mentioned before, to make sure that, for example, every student number in takes actually matches up with a real student number. So what this error is saying is that the current state of the database violates referential integrity, so we can't enforce it. That means we're going to have to investigate these tables and see what doesn't match up correctly. We'll exit out of here. And just like a table, we have to make sure we save our relationships. We'll exit out of that. And let's take a look at the takes table. So the first thing that might pop up to you is this hash symbols. This isn't an error or issue at all. Just like in Excel, if there's enough width in the column, it will display hashes. So we can just fix that by pulling this over here. That's not what was causing our error though. Let's pull this one a bit more too, so we can see what everything's called. Okay, so we have the student numbers here and the course ID here. So we have student 1 and we have student 2. So let's take a look at the student table. And here's one of our problems. So we have a student 1 here. Remember, the SN was just formatting codes, so the actual value is 1. And we have 5, 6, 7, 8, 9, and so on. But there's no student 2. So this means we've violated referential integrity here, because we have 2 for a student that doesn't exist. The other issue is the course ID. If we look at the courses table, there's nothing in here. So that means we can't have a course 1 or a course 2 if all our courses are empty. So there's a few things we can do to fix this. In real life, you'd want to actually look at your data and see what the correct data would be. But in this case, we're sort of making up the data. So in this case, we'll take a look at student. We'll see student 5 is a valid student. So we'll simply change student 2 to student 5. Again, in real life, you'd want to make sure that that's an actual student and they're actually taking this course. You wouldn't want to make up the data. I'll save this table. And the other thing we're going to need to do is we're going to have to define a few courses, at least 2. So in here, we'll make a course in the computer science department. We'll give it number 1032, and we'll give it the section number 650. And we'll say the professor is Professor 1. And we'll make another course. In this case, call it Comp Sci again, while it'll be in the Comp Sci department. And we'll say this is course 2034. We'll say it's section 1 and Professor 1. Now, once again, we're referencing another table here with Professor ID, so we'd want to check that we do have a Professor 1. And we do. That's okay. I added these between and edit. So looking back at takes, we say it says course 1 and 2, but in courses we got 5 and 6. Since this is an auto number, it fills it in for us, so we can't really change those. So instead, we'll change them here. Change this to 5, and we'll change these ones to 6. And we'll hit save. Okay. So hopefully, after those changes, the referential integrity is okay. We'll go back into the relationship tool, and we'll try setting that up again. So remember, we're trying to define this relationship here between student and takes, right here in the ERD. So we drag the primary key to the foreign key. We enforce referential integrity, and we hit create. And we can see that we created it. I didn't do the best job at drawing the line, but the line crossing things doesn't affect anything. Just a little bit not visually appealing. So the next one's going to be between takes and courses. So again, we're going to drag the primary key, course ID, to the foreign key, course ID down here. And we can see they both match up. But let's take a look at what happens if you accidentally clicked lower. So let's say I took course ID, and instead of dropping it on course ID, I dropped it on enrollment date. We could see that they don't match up quite right. And that would actually cause some problems when we try to create this relationship, because we're trying to create a relationship between 2 fields, 2 attributes, that don't have the same data types. So if you get an error here saying that relationships must be on the same number of fields and the same data types, this is a hint that there's a mismatch. So generally, a primary key and a foreign key have to be the same data type. So if you see this error, you could have 2 possibilities. One, you dragged it onto the wrong attribute, and you're trying to match a primary key to something that's not a foreign key. That's what happened here. In that case, you just have to redo the relationship like this. Make sure you're dragging it onto the right thing. The other possibility is that you set the data type wrong of the foreign key. It has to match the primary key. The only exception are AutoNumbers, which can be treated as numbers for the foreign key. Okay, we got that one set up. Looking good so far. So now we're going to drag, or create the relationship rather, for teaches and courses. In this case, once again, we drag the primary key onto the foreign key, enforce that integrity, and we're going to drag professor's primary key to the foreign key, and we'll enforce that referential integrity. That looks good. And the last relationship to define is going to be between professors and department here. And this is a one-to-one relationship, and it's chair ID that's the foreign key. Remember, these don't have to be named exactly the same. We're going to drag professor ID to chair ID. So there should already be something that looks a little bit wrong if you're paying close attention. This says one-to-many, but in our ERD, it says one-to-one. That's a bit of a problem. Let's make it anyway, see what's going on here. So now that we've made it, we can see that we have an infinity symbol right there. And it's hard to see, but there's a 1 beside another one right there. And that's a bit of a problem, because in our ERD, the cardinality isn't many to one, it's 1 to 1. So what happened here? Well, there's something that we forgot to do in the department table. So I'm just going to remove that relationship for now. And that has to do with chair ID. So if we look at the ERD, we can see chair ID here. This was that foreign key that defines the chair's relationship. And we didn't really consider the uniqueness of what this attribute should be. This is a bit of a problem. Because, for example, if we had a department called computer science that said Professor Servos was the chair, but we also had a department called engineering that said Professor Servos was the chair, they could do that the way we have our database set up right now. And then this would no longer be a one-to-one relationship because we have a professor that's chairing 2 different departments. It would now be many to one. And that's why Access is saying that this is a many-to-one relationship. So this is a bit of a problem. So how do we fix it? Well, we have to change the uniqueness of chair ID. So let's head over to the department table. I'm going to go into Design View. We're going to go to Chair ID. Remember that we set uniqueness with the index property. We want that to say no duplicates. So yes, in brackets, no duplicates. This is saying that each record in department can only have one specific unique professor. So Professor Servos could only ever chair one department, never more. So let's drag this. We'll go Professor ID all the way to Chair ID. And you can see that it now says 1-to-1, which is great. That's just what we want. And then we'll hit Enforce Referential Integrity. And we can see we have our 1-to-1 relationship. That's great. So if you're having a problem like that in your assignment or in your homework, you're trying to do a 1-to-1 relationship and saying many-to-one, you might want to look into the uniqueness of those attributes. The other thing I'll show you is why we're always dragging primary key to foreign key. If we do it the other way around, like this, we're doing chair ID to professor ID, still looks okay, but we're going to have some issues when we try to enforce it because it's going the wrong way now. So remember, it's almost always primary key to foreign key. So that's another thing to check if you're having issues. Make sure that you're dragging the primary key to the foreign key. And always make sure you save afterwards. Another thing we can take a look at now that we have referential integrity enforced, if we tried to change this to a student that didn't exist, like 2, we're going to get an error saying that we couldn't add it to this table because the student table doesn't have a student for student ID 2. And that's great because we want that referential integrity to be maintained in our database. That's all I have for you in this tutorial, but it's not the end of the content for this week. You've just watched the going from an ERD to a database tutorial, but I also have a second optional example that covers turning a different ERD into an Access database. If you feel like you need more practice with Access, I suggest you follow along with this tutorial next. On the other hand, if you feel like you have a good understanding of Access, you can move on to the Access Forms tutorial, where I'll show you how to create a simple database application using Access. This database application will be a Microsoft Access form that will allow us to enter and view some different data for that database. So links to all of these videos should be available on the OWL course site. Thank you for watching, and have a great day.